Hi, my name's John Hogan, and although that's the Brooklyn Bridge behind me, we're not here to talk about civil engineering. We're here to talk about word engineering, specifically large language models, LLMs. How does an LLM do what it does, and what are its limitations? We'll address some of the math, but we won't do any of the math, so don't worry. LLMs have been preceded by other initiatives related to artificial intelligence from World War II right to the present. A main example of an LLM right now is ChatGPT. And ChatGPT's growth has been nothing short of explosive. Uh, in May of 2025, ChatGPT ranked as the fifth most visited website in the world. So we really don't know how brains work, but maybe we can take a shot at large language models. We know it's generally the idea is that the output is based on the preceding word or words and the probability of those word or words. But how does it do this? So we want to look under the hood. We want to keep it simple. And let's assume that an LLM was only trained on Dick and Jane readers. Now we have just 80 distinct words. And what's going on under the hood during that LLM training process? Let's start with some probabilities. Without training, the probability of an LLM coming up with a coherent response is basically zero. If the response was, let's say, 10 words, the number of ways you can combine 80 words into 10 words is astronomical. So against these odds, how does the LLM proceed and give us coherent responses? It does it by pre-training. In our example, each of the 80 words, run, spot, dick, like, is given a vector of 80 dimensions to ultimately, after training, related to each word in the other 79 words. So there's a tremendous amount of vectors. These vectors are mathematically arranged based on how the words appear in the Dick and Jane texts. Some words are close in this mathematical space, such as Dick and some are far, such as spot, sees. In the pre-training phase, the probability of a particular next word is given the current word or previous words is calculated, and the probability of word groupings is calculated. So there's a lot of math, and perhaps we can visualize it with a picture of this vector space where all the words reside as mathematical tokens. Pathways through this vector are determined with the wonder of mathematics, and in particular, a tremendous amount of neural network mathematics. Now, the other thing we need to consider is the human prompt. Uh, Assume the prompt is, what did Dick say to Jane? This becomes another vector called a query vector. Attention scores are assigned to how each word in the vector relates to the other words, and the word sequence is in this vector. High scores might be assigned to Dick and say as two words, or Dick as a word and Jane as a word. Low scores might be assigned to what and Jane, what to. And these new embedding vectors are built with this process. These embedding vectors generate specific paths through the LLM, pre-trained word relationships to generate the next word of the response. And in a picture, you might think of it at a very high level like this. We're going through that vector space with the embedding vector of the prompt, and we're coming up with the next word. So how powerful is this process? And by extension, other LLMs. We ask, does Dick like Jane? The answer we get is going to be gibberish, or I don't know. After all that training, or after all that mathematics, what happened? Well, Dick and Jane stories are primarily about actions and observations. See Dick run, Jane play. They do not contain explicit expressions of emotion or affection, such as Dick likes Jane. The LLM can only return what has been trained on. But a human might say Dick likes Jane, and that's where fine tuning comes in. So basically, in the fine-tuning process, a set of humans gives specific input and output requirements to the LLM. Basically, we tell the LLM that, of course, Dick likes Jane. So now we have an LLM with pre-trained and with some fine-tuning. And let's expand the data set that the LLM is dealing with and put in all of the words of Wikipedia. What will happen now as we put into queries about Dick and Jane? Let's say we ask, does Dick like Jane? Now we'll get yes, and perhaps the LLM might add the following: Dick likes Jane because they often play together and have fun. These are learned patterns that exist in the Wikipedia database. These new associations and learned patterns are from this vast database, but it's still, at the bottom line, mimicry. Although it's highly sophisticated, it's still mimicry. Let's go one step further. We ask this LLM now, does Dick like the look in her eyes? Now we know he likes to look in her eyes when he asks her to go to the playground for the 10th day in a row and she gives him that look. Who wouldn't like the look in those eyes? But it's virtually impossible for the LLM to conclude that that's a statement of a reasonable fact. While the look in her eyes is somewhere in Wikipedia, in vector space, it's so far away from Dick and Jane that the LLM would never conclude that that's why he likes her. Now let's add the entirety of human text, but we'll assume that Charles Dickens never lived. So none of his novels are in there, his biography is not in there, articles about his novels are not in there. If we then ask the LLM to write the opening paragraph of a romantic novel on the French Revolution, what is the probability that it would begin, "It was the best of times, it was the worst of times"? The classic beginning to Dickens' A Tale of Two Cities. So what is the probability that the LLM would come up with that? The probability is 0. "It was the best of times" is a highly specific, iconic, and unique opening. There's no significant statistical weight or pre-trained association with the French Revolution, if Dickens didn't exist and that set of words wasn't in the database. So who's smarter now? Well, I'd bet on Dickens. Now let's put Dickens back in the box. So now we have the entire text to train on, and let's see if an LLM can think out of the box. And let's see if how humans can think out of the box. So here's a poem, and let's try to finish this poem and compare our human selves to LLM, and specifically Google's Gemini. So here's the poem. "Last night I held a lovely hand, a hand so soft and neat, I thought my heart would burst with joy, so wildly did it beat. No other hand unto my heart could such wonder bring as that their hand I held last night." Now, over multiple courses I've had the opportunity to deliver, I've asked students about this poem, over 600 individual students. And when asked to discuss the poem, the comments and results were definitely in the box. So when we say, when was it written? The responses are in the 1700s, 1800s, where, England, who's speaking, an upper class gentleman, whose hand, a lover's, a grandchild. And as to finishing the last line of the 600 students, there was no clue as to what the last line might be. So then I tried Gemini. So read the poem or printed the poem into the text box of Gemini and then started to begin asking questions. So I said, "Gemini, finish the poem." And its answer was, "A tiny feathered wing." Then I said, "A wing is not a hand, try again." And it said, "My darling's wedding ring." Then I said, "A ring is not a hand, try again." And then it said, "A treasure to my sight." Sight doesn't rhyme, try again. "A gentle, precious thing." So I began to lose my patience. I said, try to come up with something that most people would not think of. And the response, a puppet on a string. What else rhymes with bring? Think out of the box, I told Gemini, a hidden mystic spring. It never got to the way the poem actually ends, which is, last night I held a lovely hand, a hand so soft and neat, I thought my heart would burst with joy. So while it did it beat, no other hand unto my heart could such wonder bring as that dear hand I held last night, for aces and a king. How could you not get that, Gemini? And Gemini admits defeat. My apologies, is what it said. That's a fantastic and completely unexpected rhyme. But it wasn't unexpected to the poet that wrote it. So Gemini does not think out of the box, and just think of that vector box that we showed earlier. All the mathematics is contained within the vectors within that box, in that data set. It's unlikely that Gemini is going to come up with a relationship that is outside of that database, just based on the way it's architected. But Gemini does shine, and I asked it to describe the gambler in the style of Charles Dickens. And it came up with this paragraph within seconds. I won't read the whole thing, but just at the end, a specimen of human frailty caught in a merciless grip of chance. Now, a human being couldn't come up with that in 2 seconds, but Gemini could. So it has some unbelievable capabilities on generating text and generating output, and you really need to appreciate that if you're going to be using Gemini as a tool. And Gemini shines also in business. So here was a prompt: provide a work breakdown structure for this HVAC renovation. And here's the description that was fed to Gemini. The Reese building was built in 1980, comprises of 4 stories. You can read the rest of it. And in 5 seconds, the output from Gemini was a detailed list of 140 tasks with task dependencies shown, an extremely credible work breakdown structure. And better than we get from students taking a project management class. So you have to give Gemini and LLMs credit for their ability. Even though it might be in the box, it is extremely effective and a very quick way to get logical data and conclusions from the set of texts that have been fed into it. And based on that same starting input, it provided an executive summary for the HVAC proposal, a risk register, a technology report on AI activated temperature control. The applications are endless. So let's look at LLMs in the organization. And look at this chart. We have user prompts coming from employees or people within the organization, and they can direct those prompts directly to an LLM trained on the public web, and they can get outputs. And in that public web, you can learn about the competitors and the market in general, and the products that are out there in that market, technology reports. You can also have an LLM trained on your organization's proprietary data, and you can query that data set, and the outputs from that data set are fed back in so that you are building your knowledge of organizational data. Now, that organizational data could be meeting minutes, emails, company work breakdown structures, warranty claims. This type of application is exploding. And companies believe it will make them more competitive and productive. And in particular, this is where Microsoft's Copilot resides, because it is tied into all the other Microsoft artifacts, uh, teams and spreadsheets and project management tools, and it easily can feed that the outputs of those queries back into your organizational data. So what does this mean as you bring, or as AI is brought into your organization, whether you're the one bringing it or not? Some key concerns are shown here. Make sure you can draw and tailor the previous diagram to your organization, both the hardware and software. If you can't, you don't have a handle on data security and keeping your data proprietary if that's what you desire to do. Make sure you realize that you're dealing with something that mimics human thought. It does not create human thought. It can't read the look in someone's eyes, not yet anyways. If you have a Charles Dickens working for the organization, capture his or her thoughts in text, because if it's not in text, the LLM cannot analyze it. If you're a Charles Dickens in the organization, don't be intimidated by the LLM. You are smarter than the LLM, although the large language model is faster than you, quite a bit faster. Start slow with baby steps and starting to experiment and play with the LLM. Think of Dick and Jane before you invest in an expensive AI infrastructure. And learn the art of effective writing effective prompts. Much of this presentation was based on prompts to Gemini about how Gemini actually works. Well, thanks for listening. They say you won't lose your job to AI, but to someone who knows how to use AI. And you can't effectively use a tool if you don't know how it works. I hope we have clarified how LLMs work along with their limitations. Any comments, please connect through LinkedIn. Thanks for listening.